Welcome to our chapter 8.1 lesson videos. So this will be our first lesson into the world of trigonometry. That's what our next couple chapters are about. Today we're talking about some sort of generic basic right triangle geometry essentially, which is our kind of first steps into trigonometry. So let's go ahead, let's dive in, let's get started. This should all be a good chunk of review from stuff that you saw back in Integrated Math 2 or Geometry. All right, today we're going to talk about evaluating trig functions of acute angles. We'll do that a little bit, and finding unknown sides of and angles of right triangles. All right, so there's a couple geometry properties that we have to review real quick. We'll go through these relatively quickly. If you want to read more on this slide or write more down, feel free to pause the video and copy it down. Triangle sum theorem says the sum of the measures of the interior angles of a triangle are equal to 180 degrees. What that means is that for any triangle, any three-sided shape, if we add up the interior angles, it will always add to 180 degrees. So if you know two of the three angles, you can take 180 and subtract the other two, and it'll leave you with what the remaining angle is equal to. All right, so we'll use this one quite often. Another thing we can do with right triangles is we can do the Pythagorean Theorem. Now, this is only with right triangles. So this only works when one of our angles is a right angle. Across from that right angle is what we call the hypotenuse. The Pythagorean Theorem goes like this. It's the square of the hypotenuse is equal to the sum of the other two sides squared. In other words, a squared plus b squared equals c squared. This is one of those math things that you probably remember forever and ever and ever because it constantly comes up throughout math. Now, the catch is it only works on right triangles, and the side that has to be by itself is always the longest side, the one across from the 90-degree angle. Okay, so the longest side squared is equal to the sum of the other two sides squared and or added together. Okay. So when we are doing our right triangles and we're solving our right triangles, I often like to draw them kind of the same way every single time to keep things consistent. So if I give you a right triangle and I give you some of the values, like I give you the angle A or the angle B or the angle C, or the side A, side B, side C, I like to set it up this way where A is up top, B is down on the right, and oftentimes we make C the 90-degree angle. Now, if the problem is set up a little bit differently, that's fine. Just do it accordingly. It doesn't really matter, but I like to do it for consistency's sake. One thing you will notice on these problems is that our big angle A is across from our little side A. Big angle B is across from little side B. Big angle C is across from little side C. All right, so here's an example of a problem that you guys will see in this first section here. This is a pretty standard geometry problem, something you should have all seen before. It says we need to solve this right triangle. And in order to solve the right triangle, we need to find all the sides and angles that are missing. So the first thing we do is we draw and fill in what we're given, and then we use triangle sum, Pythagorean theorem, or maybe a little bit later on, SOHCAHTOA, some trig stuff, in order to find that missing information. So let's go ahead and let's do that. So I'm going to start by drawing the triangle. So I draw a triangle. It doesn't have to be pretty. I'm going to draw a right triangle because one of the things I saw was that big C equals 90. So I'll go ahead and label the bottom right angle as big C with that 90-degree angle. And then I like to put big angle A up top, and they gave me that. That is 55 degrees, 55 degrees. They did not give me big B, so I can write that down. And then a lot of times I like to circle that to remind myself that that's one of the things I need to solve for because it wasn't given. All right, the other stuff they gave was little a equals 7. That was given to me. And little b was given, little b equals 10, that was given. So the last thing that wasn't given was little c, which we don't know yet, but we will find. So I like to circle that as well. So we have two problems that we need to do here in order to sign. Let's take care of the easier one first. Big angle B is going to be equal to 180 degrees minus big angle A and minus big angle C. This is triangle sum. All the angles have to add up to 180. So if I take 180 and I subtract A and C. Then it'll leave me with just what B equals. All right, 180 minus 90 is 90. 90 minus 55 is 35. So big angle B equals 35 degrees. And there we go. We got big angle B. That one is now taken care of. Check. And then we got one last thing we need to do. We have to find little side C. So in order to find little side C, this is a right triangle, so we can use Pythagorean Theorem. So we'll do A squared plus B squared equals C squared. In this case, that's 7 squared plus 10 squared. And I add those two together because those are the two shorter sides, is equal to the hypotenuse, the one across from the 90-degree angle, squared. So that's equal to C squared. 7 squared is 49, 10 squared is 100, so I get 149 equals C squared. Square root both sides, and I get C, little c, is equal to the square root of 149. And there we go. We've done it. We have solved the triangle. We found that missing big angle B. We found the missing side length C. We now know all 6 pieces of information, all 3 sides and all 3 angles. So that's what it means to solve a right triangle. All right, let's give one more a try. This one's a little bit different, not too much more challenging or anything, but let's go ahead and draw a picture. So we draw our triangle. It doesn't have to be to scale. It doesn't have to be pretty. So there's my right angle, that's C. Big angle B I'll put down here is 33.7, so decimal, a little uglier. That's okay, won't really matter. We'll have to find big A. We can do that, not gonna be too hard. Just do a little triangle sum. Then we are given side length B equals 5. And side length C equals 9. And this is where this one might be a tiny bit tricky. It shouldn't be too hard, but we have to find A. And so we don't have to find the hypotenuse this time. Instead, we have to find the side length A. And so the leg A is usually how we refer to that. So that might be a little trickier. We'll figure it out though. All right, so the first thing we're gonna do is we're gonna do 180 degrees, and we will subtract angle C, and we'll subtract angle B, and this is going to give us the measure of angle A. So on our calculator, we do 180 minus 90 minus 33.7. All right, we get 56.3, so big A equals 56.3 degrees. Check. There we go. That's not too bad. And then we're going to go ahead and find little side A. So to find little side A, we got to do Pythagorean Theorem, but here's where we got to be careful. The Pythagorean Theorem goes A squared plus B squared equals C squared. So we go A squared plus B is 5 squared equals C, which is 9 squared. And so we got to be careful there because we don't get C this time, or we do get C this time. We don't get A. So we got to make sure we set that up correctly. So that's A squared equals 81 minus 25. 81 minus 25 is 56, so A squared equals 56. We'll go ahead and take the square root of 56. We get A equals the square root of 56, which is going to simplify to be 2 square root of 14, because we can pull 2 2's out, so we can pull a 4 out of that square root and get 2 square root 14. And there we go. We have found our missing side. We have found our missing angle. We have everything we need. All right, that should be enough to get you started on the homework assignment. If you have any questions, please reach out to me. Otherwise, I'll see you in our next live session. And until then, I hope you have a great day.